I
Hello.
ping Pedro.
Oh, Pedro.
Okay,
Hey,
that's
hello.
good.
Hello.
Hi.
Sorry,
Uh,
Yeah.
sorry I'm late.
no problem.
I'm
Welcome.
I'm I'm Portuguese. If I'm not late, I lose my citizenship or something,
Oh, really?
Like,
I didn't know that.
yeah,
We
it's
Turks are not
mandatory.
we Turks not really punctual too, so I feel you. Um,
Cool.
yeah,
So
I think actually we can wait a couple of minutes because people are coming in like 2 minutes, maximum 2 minutes. So we can have a
no
chat.
problem.
How are you?
Need to set up as well.
Oh,
I'm
perfect.
fine. Yeah,
Mm,
yeah,
yeah.
yeah. I'm good. Yeah. Sorry about today. I had yeah, something came up and I really had to schedule an appointment,
Oh,
and
I
they
see.
could
No
only do
problem.
it 3. I was like
We're
sorry.
recording it so
Don't
that no
worry.
one is going to miss, I believe. Yeah, don't worry.
Cool.
Yeah. And let me also share the tendency, and after that we can start if you want.
Mm-hmm.
Last
Sure.
one. We had a session with Harsh, and he also showed us Noir a bit, but I believe this session is going to be more detailed. So,
Yeah, just the basics of Noir.
yeah,
I don't
I
know how much time do we have actually. I didn't ask. Uh,
I believe like in our plans we have maximum 2 hours, but if you want like more, you can continue. I believe like I don't know. Uh,
okay.
it
Okay.
depends.
I don't think I'll have content for 2 hours, but
Okay, perfect then. No
yeah.
worries. Like I mean, sometimes it too. Um, all right. I think we can start right now. Like if you also ready. So floor is yours, Peter.
Yep. I'm ready.
Yes,
Yeah,
please.
just sorry. Okay. Um, I need to share my screen. Uh, okay, where am I? Yeah, I think yeah, this no, not this one. Wait.
No,
Uh,
you don't have a permission or not? Let me check it.
no, I do have. I'm just okay. Okay.
Ah, yeah, right now it's okay.
Do you see it?
Yeah,
Cool. Oh shit. Made the slides. Do you still see it or not
yeah,
really? No.
yeah, we see it.
Okay,
It's
cool.
full screen.
Yeah.
Yeah.
So this is what I call learning what in an afternoon or get your money back. Maybe I shouldn't have these. I don't know if the workshop is paid, but anyway, I'm not giving you anything besides you're gonna learn how to write noir in an afternoon. But actually, I'm gonna do better than that. You're gonna learn noir in 1 minute. So I hope you're ready.
I told you
Um,
2 hours, but if you need only 1 minute, so perfect then.
yeah, this was a totally not generated AI image that I took in a hackathon, and there was some person. You see, even the cook is I don't know why, just randomly in the middle of a table. Yeah, but there was this person that was like, "Yeah, do you know Rust?" And the other guy was like, "Yeah, yeah." And of course, he had to tell that he uses Arch because if you use Arch, you always have to tell that you use Arch. Uh, and then she's like, "Cool, then write Rust," and that's it. Like that's how you'll write Noir in 1 minute. So good. Okay, I'm joking because you may not know Rust, and so if you don't like I had at the beginning, then maybe you want to know a little bit more. So it can't be exactly the same, right? Right? Uh, but first, let me just like give on the rant about like how ZKVMs aren't actually ZKVMs, and because they don't have ZK nor privacy, they're just succeed. Okay, no, I'm kidding. I can spend time on this rant, but I'm gonna talk about ZK for zero knowledge, and then yeah, why do we need Noir, and why is the whole thing about Noir, and then finally we'll just gonna casually achieve global peace in an afternoon. So I may be overselling that a little bit. Anyway, ZK for ZK means zero knowledge for zero knowledgers like me, and I guess some of you as well, at least. You can bring your own imposter syndrome, like I am, because I really I have no idea what I'm doing at most of the time. But I know that ZK is actually very simple. People go like, oh, you have to have a PhD, whatever. That's not true. Because see, if you start with the basics, like you have um so if you're following and you're like, okay, sure, I am following. Now you can basically, it's very easy. You just can observe that this is also true. And so yeah, that's the problem. It's like every single article or paper or book on ZK, it's always like this. Oh, it's very simple. It's just an equation. And then very easily you're like PhD maths and you give up because it's just too much. And so why am I doing this to you? So you understand what are the feeling that prompted to Noir to exist. Like nothing ever was easy. You're like, oh, there's other languages. Yes, I started with using Socrates and Circom, but it was never this simple. And so, yeah, we were there. I mean, this not 6 years ago, it's more like 8 years ago, where we started figuring out our own zero knowledge, like just like Zcash, you know. Yes, we will go and do like Zcash, write the constraint system ourselves, and we did it, and we are still alive. Then there's came this idea of circuits. I mean, circum comes from circuits, I guess, I suppose. So it's the idea that you can actually make programs, because ZK in a way behaves a bit like, you can think of it like as a electrical circuit. So if you go down that road, then you can have these different gates and components. You can attach one to others, and they kind of look like circuits. So there was this idea of circuits. And then 2 years ago, we were like, okay, this is not good enough. We wanted something that really abstracts away all the math. You can write the ZK and don't have to understand the math. Good if you want to, but you don't need it. And so that's the fundamental idea behind Noir, and we've come a long way since then. So why Noir? Well, this is no meme slide. I put memes in every slide, so I promise. So first of all, like ZK is good. We want to prove statements, computation without revealing some of the inputs. This is very important for RTech. So it's not like we're doing this just because, I don't know, we have nothing else better to do. We do. It's just like Aztec contracts are zero knowledge circuits, so they can be Noir programs. So each function is one Noir program, essentially. More than one, actually, but anyway, but ZK is also hard. Like, again, the problem is like, we wanted, they were, no matter if you have like this circuits idea, it was always going to be, you're going to be counting bytes and counting bits and moving them, and then decide on whether you want to use little endian or big endian bytes or whatever. So we wanted to do something better. And so Kev likes Rust, which is a famous thing that we do, that we say, because he really likes Rust. So he created a language called Noir, which is just a copy of Rust. So Kev was the OG, the real the guy that came up with Noir. And yeah, we basically just wanted to copy a nice language, and a nice language was Rust. So that would be the Rust. Could be any other. It's just like this one. So after 2 years, this is actually very good. And to be honest, I was preparing for this workshop, and I was like, okay, let's see, like what changed in the latest Noir versions? And nothing. Like it's insane. Like it's just faster, and it's just faster. It's like very much optimized, but you don't actually notice in terms of having new stuff in the core language. And this is amazing. People are building tools and libraries and everything outside of the Noir team. And this is exactly what we wanted. So the language itself, it's fairly, let's say, at syntax level and everything, it's fairly unchanged since, I don't know, 6 months ago. So I'm actually impressed. And there's no magic in ZK, it's just math. And it is the de facto ZK standard. I mean, I couldn't say this 2 years ago or last year, and yes, now I can. Like most of the ZK projects in the wild are using Noir. Since, I mean, from world to pay to Aztec itself, obviously, is using Noir all the way. So I don't think there's anyone in their right mind that will choose another language to write their front end, because yeah, it's just yeah, I don't think there's any other contenders at the moment. So what do you want from a zero knowledge language? You want it to be fast because you don't want to spend more than 10 seconds without Twitter. Like, because yeah, one thing with proving on the phone is like you actually have to stare at it. So it's more painful than just waiting, you know. You're like, you actually have to put your phone down and then look at the world. And that's insane. Like, no way I'm gonna do that. So you also want it to be powerful. You can say, okay, it's faster to write, but then it doesn't do much. That didn't make the cut for us. We wanted to be powerful, more powerful than the languages that were already available, and then for them to be usable. Yeah, so with a good UX, something that you could do on a phone, and mobile phone proving is quite hard to do because of constraints, especially in the RAM when you're running stuff on the browser. It really it makes you suffer, especially on iPhones. But yeah, you can do them on like ZK Passport is doing with a native app, and then you basically have very, very powerful CPUs on phones that make proofs very, very fast. So yeah, maybe for mobile apps, people are leaning more towards mobile native apps than web apps. So some examples of the language, if you haven't seen them before. A simple guessing game. So when you start with a first project, this is the example you get. An X and a Y. So you have an assertion that will say, yeah, this program proves that X is different from Y. So one thing is important, it doesn't not only execute, it proves. So it kind of implies that you know what the result is, right? It like you know what X and Y is, you know that they are different. You just want to prove to your opponent in a game, for example, that they have failed, that X is your private input, that you were thinking of X, and your opponent gave you Y and they failed, and you want to prove that your X is different from Y. So, I mean, you can also see why wouldn't this work, because I could just change my number X at any point and just make you fail all the time. So it's not this simple, but hopefully this example will give you a hint of the syntax. Actually, you would use this one together with the pre-image knowledge proof, where you would say you would commit to a hash of your input and then say, I'm proving that I haven't changed my input, and then I'm proving that you failed. So that would how a game would go, but it could also go with the password hashing, for example. Usually when you're doing backend development, you are use the registers on your website. So it will like, when it registers, it gives you a password. You receive the password in plain text. Yes, it's encrypted via HTTPS, but you still get it like plain text. And then you go and hash it, salt it, hash it, then hopefully salt it and hash it. Some people it's like, just gonna store plain text. But yeah, if good practice is that we will salt it and hash it and store it. But at some point, they had received that in plain text. And I've seen way too many cases where they just casually log all the passwords that come in before hashing them. So there's many ways where things can go wrong, and especially if you are registering in a website, you are actually sending your password. This is insane that you are sending your password to someone else, and then it's up to someone else to manage it correctly. Even not being malicious, it's very easy to make a mistake where your password is logged. So a better way is using zero knowledge, where you could say, I'm proof that I know my password, and I'm not giving you the password. I'm giving you proof that I know my password. So basically, you would hash your password and send the hash with registration and say my username is zpedro and my hash is 0x123. And then when you want to log in, you would just make a zero knowledge proof and say proving that the hash of the password equals 0123 and send that proof to the backend. This sounds complex, but if you see, like in Noir, it's actually very simple. Here the example comes with a Pedersen hash, which is probably not the best. Best would be like maybe Poseidon. But anyway, you just hash your private input and then prove it is equal to the public input. So the public input would be hash. So you would send the public input, you would send a hash to the server and say, if you receive a proof that someone knows what's the pre-image of this hash, then it must be me. So yeah, this is just better logging in like than we are used to do. Yeah, I guess nobody yet did like some kind of OAuth, or sorry, some kind of OAuth or Auth0 or Passport.js library should do this. Also because maybe they would want to use a different hash like Bicrypt or something. Not just Poseidon.
Can I
But
ask something?
yeah,
Sorry.
yeah, sure.
But if I generate a proof, I can use it
Mm-hmm.
one time, right? Like,
Yes.
so that if someone got that proof, they can also use
Yeah.
it. Yeah.
Yeah. Yeah. Of course. I mean, this is you'd have to have like when you log in and receive a salt and then prove with the salt and then so the verifier would use the salt. So I'm just giving still like very simplified examples, but I see what you mean. Of course, like you'd get something from the server before generating the proof, so you know that that's idempotent like login session and not something that could be reused. Yeah, I see hands in here. Yeah.
Yeah, Pedro. Basically, I wanted to know if you can put some light more on Pedersen hash. I've been exploring this, but if you can give some more information on that, would be great.
Yeah, we don't use Pedersen hash that much these days. We use Poseidon, which is the most efficient in Noir and Rothenburg. Pedersen hash has a cool thing. If it's a commitment, it's actually homomorphic. So it's really cool because you can have like two Pedersen commitments, and then they are encrypted, they are hashed in a way, and then you can like make sum sum up those numbers, and they will get to an encrypted number as well. So you can make homomorphic operations. So we do use for some things in Aztec, but honestly, like most people using it for Noir circuits, we just use Poseidon rather than Pedersen. Also, like the community prefers Poseidon because it's fastest. So you get a ton of libraries like writing Poseidon in JavaScript, so you don't have to run an R program to see what's the output. So there's many, let's say, you just go with the flow, and as people prefer to use Poseidon, you will likely also prefer to use Poseidon.
So, sorry to ask or continue on this. Basically, we're building a poker game And in that, we've been exploring Pedersen, and we kind of made progress. But do you think we should explore the thing at the same route, or you say suggest for a game like a poker game, it's better to go the Poseidon way?
Yeah. I'll just go use Poseidon for everything. So the reason I have Pedersen here is just because I made this slide some time ago, and I just didn't update it because at the time Poseidon wasn't in a good position, and we improved it because we use it very often in Aztec, and yeah, that's why Pedersen shows up here. But yeah, I would also use Poseidon for, unless you actually need Pedersen for one specific reason, I would just use Poseidon.
Thanks, Pedro. Oh,
Yeah, cool. So more examples. Semaphore. So I don't know if you know Semaphore. This is a classic example using ZK where you're member of the real human group. And I'm saying this example because you probably heard about World ID, and World ID is exactly it's a complex semaphore, but it is semaphore. It is no more than a semaphore. You just have a group of humans, and you are proving that you are a member of that group without obviously revealing who you are. And so basically, you just call this computer Merkle root, which is already existent. Actually, you probably use a library to make it even easier. And basically, you are like proving that you know, in this case, an address, which would be you, with a Merkle path that you also don't reveal, at an index that you also don't reveal. And the only thing that is publicly known is the Merkle root, is the top of the tree. And you're basically proving that the root would, it is that you are a member of that. That basically saying, yeah, my leaf, my address is in this tree at this index for the tree with root whatever, and you don't show what the root is. We use this very extensively in everything that is, I guess, any ZK project. Any ZK project has semaphore and Merkle trees everywhere. So when people ask me, where should I begin if I want to learn more about ZK? Go and write Merkle trees, because Merkle trees are the core of, maybe the core of blockchain in general. So proving that you are a member of the Merkle tree without revealing who you are, which member of the Merkle tree you are, this is very, very valuable. So this is as you can see, a semaphore circuit in Circum would be like 10 times this size and 10 times less readable. Yeah, this is how you do it without an external library in Noir. With an external library, you just import zkKit and then say NT membership, and then it would be much easier. I can show you a zkKit later on. But this is it fast. And then this is where I lose my mind. It's not even true anymore. But people ask me about that, still ask me about that, because historically Noir was a bit slow in the beginning. It triggers me a little bit. In any case, it does depend. Like, depends on which backend you would use. It is backend agnostic. So currently, actually, the only backend that works, I think, is Berettenberg. But there's Warlady is working on a different backend, which is called Weird. I think Weird. And then I heard yesterday that there is a team working on a Plunky 2 backend as well. So yeah, basically you write Noir and it transpiles to an intermediate language, and then that intermediate language is what will be going to your backend proving backend. So in this case, it will be Baratamorg in our workshop, but theoretically you could use different ones, and they have different trade-offs. Some are faster, some are not. So you go choose your poison. Actually, these days with the ZK cache crazy, everyone is talking about trusted setups, and this is an example where you would actually use Berettenberg, because Berettenberg uses one trusted setup, like the previous version of Zcash, where you have one trusted setup, and then that works for every circuit. Zcash nowadays doesn't even use trusted setup. They are like one level. They are the kings of ZK, I guess. So they have come with Orchard, and the new pool doesn't even have a trusted setup. We're not there yet, but we have one trusted setup. With Gross 16, you have to actually have one trusted setup for each circuit, which is kind of a pain. And wouldn't be usable for us. Like we really need one trusted setup that works for every single smart contract. But the speed also depends on your program. Like even if the Noir team doesn't like me to say this, truth is like if you know how the language works, if you know how the proving system works, you will be able to optimize certain things. They're like, oh no, the compiler should even if you write stupid code, the compiler should get to a best the optimal speed, and that's unfortunately that's not there yet. But have to ask you, how much does speed mean to you? Like, do you wanna spend 2 months to save 15 milliseconds of proving time? Maybe you don't. And that's exactly what I wanted to go. In the end, it's all you care is about the app that you're building. If you're like using Groth 16 and you have one trusted setup for every circuit, your user doesn't even know what it needs to prove, and you're already downloading 300 megs of proving key. Because each program has its own Z key, and that's insane. With Noir, it's like you download. So ZK password app, for example, is like 80 megabytes in size because it already comes with the CRS. So it's like, okay, and you don't have to think about that anymore. It's like even the trusted setup wasn't there yet, even. So yeah, I'm like everyone that complains that Noir could be. Do you have benchmarks? And it's like I've never heard of someone that is actually serious about building apps and that cares about these 200 milliseconds that you may get. So yeah, I honestly don't see what the problem is. It's also the only usable ZKDSL, and I already mentioned this a little bit. We want you to write code and not circuits. We don't want you to think about math at all. We want you to write the code as you are used to, and then out comes a proof and a circuit, and that's it. We don't say Noir circuits anymore. We just say Noir programs. Again, the idea of the Z key, where like yeah, if you use a different backend, which would be the default for Circum, for example, you basically need the proving key for each circuit. So if your Merkle tree is 1 to the 8 size in leaves, then you need one proving key. But if it's just slightly bigger, then you need a different one. And that's stuff that your user has to download, whether on the browser or on the phone. That takes time, no matter if you're, I mean, you can't rely on that. So another thing that people complain is the gas, the fact that Noir is like plonk. So the output of the Bertenberg proving system is expensive, and yeah, it's more expensive than some of the other proving systems, but in most cases that's not something you're going to be worried about. We're more likely to go and use proofs in recursive proofs than actually to pay 200k gas to play battleships or Wordle on an L1. Like ZK is always going to be expensive. Like 200k gas, it's always going to be expensive for anything that you're going to do. So, and then finally, the fact that Noir is very, very, very much mobile friendly. So you want something that needs to prove mobile flawlessly on a app or a website, then yeah, then you need these very lightweight, trusted setups and architecture and very, very simple things that you can do to prove. Okay, we're not achieving global peace in one afternoon. That's not possible. So let's just go and see some Noir tooling and then write some Noir code and then proving some Noir stuff. So here's the stuff I usually show. Here's the Noir Discord if you want to ask questions, show work, whatever. People are pretty helpful there, so you can visit the Noir Discord. Noirlight.org is our brand new, beautiful website. Also where you can find the docs. Docs are very useful if you want to know like all the data structures that you can use, arrays, slices, bounded vectors. So I use it myself very often where like I just know if I have like I was trying to concatenate two arrays just yesterday and I was like, I don't know, I don't remember what the syntax is. So I just went there, just go to concepts and get the slices, the arrays, and there was a method called concat. So, and then you can visit this Sterling link tree. That's my link tree. But more than all, it has the workshop resources. So it has like a code space you can run, and I didn't double check it if it still works today, but that workspace will it's a code space, so it's a virtual machine that is working on somewhere in Microsoft. With already comes with Brettenberg and Noir by default, so you can use it if you don't want to use your own machine right now to follow the workshop. There's also a cheat sheet which I'm gonna be using a lot because I don't remember half of the commands, but I'm gonna explain everything that's going on. Cool. So I think we're good. I can just change the screen that I'm sharing if I can find how to do that. Okay. Cool. So I'm sharing my
Sorry, before we
laptop.
move on, someone asked something
Yes.
that maybe you haven't seen. Let me just tell it to you.
Or the chat. Oh, sorry. No, I wasn't seeing it. So
Tina asked, how does Noir compare with provable programming language like Cairo, I believe? Yeah.
Oh, I mean, the biggest difference between something like Noir and Cairo is that Cairo is not zero knowledge. So it makes very big computations produce a very small proof. I mean, in the case of Starks, they're not so small, but they are very succinct in comparing with the rest of the computation. So you can prove the computation of very big chunks of data in a small proof that can be cheaply verified. But you can't hide anything. And so that's why I tend to say that Cairo is not ZK. It's a succinct language. And if you go to StarkNet, they are very clear about that. They're like, StarkNet is a succinct. It provides succinctness, not privacy, and that's fair. And that's honestly, I wish other projects would do the same, because most of the ZK that you hear in Twitter is not actually ZK. So
more
our Discord link has expired. Yeah, I mean, this serves different purposes because if you use Noir, you are producing a snark and not a Stark, so that comes with some trade-offs. So there's just like, just gonna send the link for, okay, how they, trying to say, okay, I sent a Discord invite link. So yeah, that's how it differs. And actually, there's one cool thing, and we love StarkNet, and because what they have done is you can actually write your program in Cairo and then use Noir to provide the privacy. So basically, we can verify Noir proofs in Cairo using a framework called Garaga. I'm gonna write it here. And so if you like StarkNet at Cairo, you should go and see Garaga. It's a big deal. They have done an amazing job. Cool. So going to my terminal here. I hope you see it. No,
Yeah,
no,
we
you can't.
see.
Hey, you're seeing my terminal. Very good.
Yeah.
It's okay. Okay, I see my screen now. Okay, cool. So just move around some windows here so I don't get caught. Okay, cool. So we have a new project. The first thing we want to install is obviously Noir. So the way you install Noir is not very different from the way that you install Rust. So if you have Rust, you know that there is a script that installs RustUp, and RustUp will manage all your versions of Rust C and Cargo, which is the package manager, runner, tester, like whatever. Everything in Rust goes through Cargo. And so you install RustUp, and then that will allow you to install the various versions of Cargo. And the same with Foundry. You install Foundry up, and then you run Foundry up to install the various versions of Forge, Anvil, Chisel, etc. So Noir is the same thing. You install Noir up, and then you run Noir up if you want to change different versions of Noir. This is very interesting. So if you see in the cheat sheet, but since this is a virtual workshop, I can actually put here the link to install Noir up. So you can just paste it, and then you install Noir up. So you can see where Noir up, and you can see here's like in this folder. So so now when I run Noir up, it will grab the latest version of Noir. And that would be Nargo. You see, RustUp installs Cargo, so Noirup installs Nargo. That's Nargo Cargo. Yeah, I guess Kev really likes Rust, so he was like, I'm gonna use the same. So now you have Nargo, and you can see Nargo version. And it will tell you what is the latest version of Nargo that you have. The latest, the most stable one is beta 13. So that's what you get. Another thing that you want is a proving backend. So Noir is just a language you write. You write programs in Noir, and then you have the different backends you can use. Currently, the only one I use is Brottenberg. So that's what we're going to be using today. Yeah, Augusto. Yeah.
All right. Well, in my case, I already installed an Argo, but
Mm-hmm.
my version is beta 9. Uh, can you show me the command in order to update the version, please?
Yeah, I'm showing it on the screen. I don't know if you're seeing it. Maybe it's not really. But yeah, just go Noirup. Assuming that you have installed Nargo using Noirup, you should just be able to run Noirup, and it will get the latest version of Nargo. Then that's it. I mean, what could be is like you have a very old version of Noirup, and in that case, you're gonna go and maybe delete this like RF and then delete Noirup, then go back and install it again with this code command, and then yeah, it will install Noirup again. So after calling Noirup, you'll be able to get the Nargo version, and this should tell you 1.0.0/beta.13. Cool.
Okay.
So
Thank you.
yeah, no problem. So as I was saying, then we need a backend. So we're going to use Berettenberg. Actually, there's documentation about the Berettenberg at berettenberg.aztec.network here. If you want, it's very simple and very stupid, but we needed to make this split. But I mean, it's a documentation website, just like any other. So, but yeah, you install it with another call command, and again, bb-up is again bb-up installs bb. bb stands for Berettenberg. So if I go and I run this command, I'm gonna get bb-up. So I can see where is bb-up, and then now I go bb-up, just call bb-up, and what it will do is say, okay, I'm gonna get the latest version of Nargo and then install you a suitable version of the backend that works with that version of Noir. So, which is not what happened here. Okay, I think, I don't know, it's installing it here. I should still have bb-up, yeah. So if I run bb-up now, yeah, now I get the version 1.2.0. That's the version for beta 13. Yeah, so that should work. I don't know why it's installing this NVM version something, I don't know. But yeah, I don't know. Anyway, you should now have a version of BB, so you can call BB version and see the version 1.2.0, which is one version that works well with Noir. So that's how it goes. So the flow now is that we're going to write a Noir program. So I've shown you the Noir tooling. I've shown you Nargo, bb-up to install Nargo, and Nargo to test and prove and check and do a ton of other things. And then we install bb-up, so we can install bb, and bb will prove, will generate the solidity verifier, will generate the verification key with verify, will do other things that are like backend related. So having these two, we can now start with a new program. So that will be Nargo. In it, I'm going to choose a name. I'm going to call it workshop. And I have a program, so we can see how it is. You've seen this before in the slides. A guessing game, right? I'm proving that X is different from Y. Okay, so we can make this more interesting because we have more time. So we can say age verification. Let's say age and then minimum age. So it's more interesting. Cursor is already telling me that I want to prove that my age is higher than minimum age. This is quite important in the EU these days, where they're using age verification for adult content websites. So like you want to prove that your age is higher than, okay, something. So yeah, anyway, that your age is higher than. Okay, I'm clicking the debug. Yeah. So fields can be compared. It tells you what the problem is. So you need to cast it to an integer first. I'm gonna go age as U31 and then minimum age as U32. So I was expecting cursor to be more useful here. Usually it does fine with Noir, but anyway. Now I'm basically casting these two values to unsigned integers. Because
could you show again the command to create the Noir project, the Nargo init
yes,
one?
Nargo init / name, and then workshop. You could just go Nargo init if you want to. So if I was to verify my age, I would say, yes, I am 36. I am over 18 would be the usage for the European Union. So I want to prove this without revealing anything about anything else about me. Again, this is a stupid example because I could just go and change my age, right? Or just lie, okay? but I'm just trying to be helpful in learning and not doing good examples. I guess you in the real world you would just use ZK passport and use your own passport to prove that your age for that passport with your face is actually higher than the minimum age, and that's much better than whatever we were trying to do here. So you were probably asking also, like, wondering what is this field thing, and field is just a member of like a finite field. So it's just the way that you represent numbers in a finite field. But you can always cast them to your U32s or anything, and it will go and apply some range constraints and some range checks, which are slightly more expensive, but not really. And so then you can compare them. Yeah, so you can't compare fields. That's what I mean. And then there's this testing. So you don't actually get this in most DKDSLs, but this is very, very cool in the case of Noir. Because see, in this example, we want the verifier to input the minimum age to be 18. Everyone knows what's the minimum age. What I don't want to reveal is my age. So in this case, you would go and say minimum age is 18, and my age is 35. So if I run this test, and actually you can click here to run the test. It will just say that didn't report any output because I didn't debug anything. I didn't put anything to debug this. You can actually have debugs if you go on the Noir documentation. There's a debug log or something that you can output stuff. But yeah, it didn't output, but it did. It worked. You can also run this with just an Argo test. You get this little thing if you install the Noir extension. So you go to the marketplace in VS Code or Cursor or something, and then install Noir. And then you get the syntax highlighting and this little really cool stuff where you can run and debug the test. But if you run Argo test, it will do the same thing. You will also in your circuit also prove that some test is supposed to fail. So you can go test should fail, and then say, sorry, I'm trying to see. I think it should fail. I don't remember, but let's try this and see if this works. So this test is supposed to fail. So I'm gonna run Argo test. So it's supposed to fail, and it did. It did indeed fail. So the test passed. Okay. So if you're used to write test sheets, you know that you want the happy path and then happy path. So you not only want to prove that it works with the correct input, but it also works with the incorrect input. You want it to fail, prove that it fails. And there's even, you can also have like with and say an assertion and say invalidate, and then put like assert here and then put, I think, invalidate. It's been a while since I've written, so I don't know what the syntax is, but the docs you're gonna find the way of passing what exactly you want it to fail with. So just gonna delete this because I don't have this in my mind. I don't remember exactly what the syntax is. But you see what I mean? Test should fail. I'm just gonna leave whatever.
Can I ask something?
Yeah, sure.
In the function declaration, we just say age field, but can we also give parameters type? Like in the following line, we say as, integer or something like that. But in the definition, can we say that, oh, this is going to be only integer or something like that?
No, I mean, this will go and be cast to a field, what you can do is like just pass a new 32 here, and then
Okay.
don't have to have this.
Okay.
And then these numbers will be interpreted as integers. So yeah, whatever.
Thank you.
It's like Rust. It casts to what makes sense, and if there is nothing to cast to, it will complain. If it can't get what it's supposed to be casting to, it will complain and say you need to cast it to the value you want. So if you go ages filled, I don't know if you could even do this. Exactly, it was expected type U32 and you're passing a field. So when it's just wrong, it just tells you. But you also don't have to put as 32 because it already knows that it's supposed to get a U32. So if it can cast, it will cast. Yeah, it's very smart. But this is just Rust. I'm saying that Rust is smart.
What is the extension that you're using in VS Code to get the nice colors?
It's a Noir. You can install it. Just
Okay.
yeah. Cool. So this is cool because you can have a circuit and you can have a whole test suite just for that circuit. So you know that there is no problem in the way that things are proven, which doesn't mean that anything is actually, I mean, you actually want to prove, not just the test saying that it's correct. That would be useless. So to prove, we want any kind of proving in any ZK language has two things. You have a witness, which you can think of it as a kind of a solution to a circuit, and then you have the proof. And both are private. You don't want anyone to see your witness. But not both are private. The witness is private. You don't want anyone to see your witness. You want people to only see the proof. So what Noir does is generate the witness. It will compile these into this intermediate language that I'll show you called ACIR. ACIR stands for Abstract Circuit Intermediate Representation, ACIR. So when you compile this, it will compile to this ACIR. Okay, yeah, Siri is waking up, like, yeah, I say ACIR, and my iPhone thinks I'm saying ACIR, so yeah. Anyway, so when you compile it, you get into this intermediate language, and then you can generate the witness, and that's what you're gonna feed into the backend. So to start with, you want to go and run Nargo check. Nargo check will basically just check this and say, provide a file that you can put your inputs in. You're gonna say prover, and then you have a prover.toml, which is a private file, like a file you don't want to send to anyone, where you can put both your public inputs and private inputs. I'm gonna put my private inputs, which will be 35, and the public input will be 18. So when I prove my program, when I execute to generate the witness, and when I prove it to generate the proof, my verifier won't be able to change this, and my verifier won't even know what this is. This is private. Otherwise, it will fail. If the verifier tries with a different value, it will fail. In reality, in this situation like this, you actually make this in the code. We'll say not even have minimum wage, just say bigger than 18, right? But anyway, let's just go with this as an example. So now you have prover.toml, so now you can go nargo execute. And this will execute your circuit. And it will compile your circuit. There's also nargo compile, which will only compile, but I don't care. I want the compilation and the circuit. So I go with and the witness. So I go with nargo execute. And I have two files showing up in my target folder. One is the witness, which is not really useful to see what's in here. So it's gzip. And then I have the JSON with my program. So I don't know if this parses. Let's say JSON. Yeah, would be cool if we could beautify this. Anyway, let's just have a look. This is what your backend will read. Backend will read this file, and it will read this file so it knows what the version is, because it needs to know if the B version supports this version of Noir. Then there's a hash of the circuit, which I honestly don't know why is it. And then it's the ABI, which just tells you exactly what are the parameters, type, etc. for every single input. In this case, it's just 2 inputs. Will be just age, and then which is private, and then a minimum age, which will be public. There is a no return, and then it will have the bytecode. So this is what the A series. This case, it's not too big, right? So okay, it's not very big because the program is fairly small, but this could actually become big. And then there's this file map. I don't know what this is. So this is what your bytecode is, and this is what we're going to be using to prove. This is even a debug symbol. So the proof is actually small. The witness is actually fairly small. If you want to, you can see Nargo execute, and there's a way to see yes here, but I don't know what the command is. This will be print is here. Let's see. And it will tell you, like, it's a bit like you could actually analyze this if you want to learn how ZK works, because it will tell exactly what expression is and how they are evaluated. So this is what is going to go into your backend. Now for the backend. So let's say I am Bob, and I want to prove that my age is higher than 18. So what did I do here? Oh, I entered the debugging. Oh, okay, don't want to debug. Yeah, it works. So let's say that I am Bob. I want to prove to Alice that my age is bigger than 18. So I've generated my witness, compiled, I generated my witness, and now I want to generate my proof. So to do that, I'm going to use Berettenberg. So I'm going to go Berettenberg proof. Actually, first of all, I need to export the verification key. So I need to say, whoever is verifying this, which will be Alice, needs to know that I can't change the circuit. Like this is it will be like instructions on how to verify this circuit. So I can't actually go and run and change the circuit later on. So I do that by writing the verification key, which is not different from writing a verifier contract for insolidity. It's just an instruction, like a key on like a representation of this circuit, and how to something that you need to verify. So I'm gonna go and write that. Write VK. I'm gonna point to my JSON. So I'm gonna say target and say workshop JSON, and then the output of my verification key would be in target. I'm going to pass this weird parameter called Oracle hash kcheck. This means that the hash used to generate this verification key is kcheck. And this is important because for validity verifiers, they are more efficient if they use kcheck. So you want to use kcheck if you want to use it in a solidity verifier, which is I'm gonna be doing that later on. If you want to verify like just a proof in another machine or using like proofs within proofs, for example, you just not pass this Oracle hash. And I have my verification key, which is also unreadable, and I don't care. It's not. It wouldn't be very interesting as well. So this VK is basically the way that you can ensure that your verifier will use the same circuit. because the verifier will also export its own VK out of the same circuit and get to the same VK. So now I'm ready to prove, and I'm gonna go with BB approve, and I pass same thing, pass the where my witness is, what my circuit is. I'm gonna pass where my witness is. It's gonna be target workshop dot gz, and then my output, my proof output. So the output is also gonna be target. Okay. So also need the Oracle hash. So I'm signaling that I'm using this hash for my for the circuit. So when I go and I run proof, you see it was fairly fast because it's a small program. But you see proof and public inputs. It's not like you can see a lot of things here, but one way you can make it like easier to read is to pass output format as well. So you have multiple output formats, and one that is useful is bytes and fields. Bytes and fields. So it outputs the proof in this weird thing that we're actually going to be using, but also it puts in fields, which could be useful for, I don't know, maybe Aztec. I don't know how we are using this. So you basically, if you want it in a Solidity verifier, or just like remove 0x and just concatenate them. We're gonna be doing that in an easy way. But you also have like your public inputs. In this case, it's 12, which in hexadecimal be the 18. So yeah, now we have this proof. Like this is what Alice will want to verify. So to summarize, she wants to, given the same minimum age, she can change this, but she will prove that Bob has more than minimum age without knowing what is the actual value of age. She just knows that the proof provides, the proof just attests that the age is higher than the minimum age. So let's imagine that now I am Alice and I don't have most of what's in here. I don't have this, I don't have this, I don't have this, and that's it. All I have as Alice, all I have from Bob is the proof and the public inputs, which I know what they are, right? I already know that they are 18. Usually in a smart contract, you have these public inputs in the contract, so they are public. So if I am Alice, I'm gonna go and do the same thing. I'm gonna go, Nargo compile, or Nargo execute. Sorry, Nargo compile, because I also don't have proof.toml, right? I also don't know what stage is. So as Alice, I'm gonna go and Nargo compile and export the verification key. And the verification key will have to be the same as Bob. If it's not, then we are not using the same circuit, so we can't actually talk with each other. Like I wouldn't be able to verify a proof for a circuit with a different verification key. So I am Alice, and I'm gonna go and say write VK, point to the same compiled contract, and use the same target, same Oracle hash, and I'm gonna get the verification key. I can assure you this VK is the same as Bob has. Okay? Trust me, bro. It's the same one. So now I want to prove Bob's claim that that his age is higher than 18. So I already have my proof here. So I'm gonna go and say BB verify. I don't know what the parameters are, but I can pass the path to proof, the path to verification key. That's it. Like, and of course Oracle hash as well. I'm gonna go BB verify, and the proof will be at target.proof. So proof would be what Bob sent me on WhatsApp, right? Or whatever. Like he sent me just this proof. I don't have anything else. I have the circuit. I know that we are working with the same circuit. And I have this proof. So he has sent me proof, so I'm gonna pass to the proof. And I'm gonna also pass the verification key, which should be also target VK. And the public inputs, right? You need to pass the public inputs, which will be target public inputs. So this file, or this file, maybe this one will work as well, but they are the same. And okay, I forgot the Oracle hash. Oracle hash, good job. And now I have having only the proof that Bob created, that he's older than 18, I can, using just that proof and the same circuit, I can be sure that he is older than I have successfully verified that. This is already quite cool, right? Very, very cool. You can have games like this. But most of you are probably here because you want to put this in a smart contract. That's where most of the interesting stuff is, because if this is non-interactive, so Alice didn't have to ask Bob for anything, right? Alice just went on and just said, okay, given what I have, this is it. There was no interactiveness between Alice and Bob. She received the proof, verified the proof. So people were like, well, what if I could put this in a smart contract? So it's not even another person that is verifying. And that's exactly what we are going to be doing. So basically, the way it works is just take this verification key and put it in a smart contract. And so we do that by writing the solidity verifier. Right, solidity verifier. Let's see what this takes. It takes the verification key path, which will be target. Okay. The output, I'm gonna put targets age that's all. Or I don't know if I can pass the name. That's it, right? So it's a directory. Okay, target contract. Okay, cool. Contract that's all. So now I have a verification contract. This is very complex stuff. Like, no way you're going to learn ZK by reading this, okay? But the most important part is this is where the verification key is. So that this thing is somewhere here. And then there's like instructions on exactly how to verify this. At the end, you're going to get what we care about, which is the honk verifier. So honk, we call it honk because it's a ultra optimized Plonk. Yeah, it's I don't know, highly optimized, not ultra, highly optimized honk. So it's like the third generation of the proving system Plonk, which was created by Zach back in, I don't know, the 17th century. So this is what we care about. We care about a function called verify. We care about this interface. One thing is cool about this interface, it is view. So you actually only pay the gas if you want to. It's basically gasless, but what's the use if you can't use this in the contract? So if you use it in the contract, then for sure you're gonna pay the full cost. But if you just want to verify something really quick, you could totally do that in Solidity without paying gas. So let's see how we would do about that. I'm gonna try with Remix. I don't know if you've used Remix. I'm gonna share my screen, my other screen. Share here. Okay, so I hope you're seeing my Remix page. So I'm gonna create a new project, create a new workspace, create a basic project. I think even Noir thing here. Never tried it, but yeah, there is. But yeah, let's try with a simple example. Okay, not basic. I want a blank one. Blank. So it has nothing. Cool. So now I'm gonna create a contract.sol. I'm gonna paste the one that I've just generated. They'll say, please don't paste code. I say, yeah, sure. And that's exactly what I'm gonna be doing. So I can compile these now. So hopefully it will compile. It'll say, oh, it's too big and everything. You can actually add some optimizations if you want to. And that's probably not enough yet. But anyway, it has compiled anyway. So you can now deploy it. So we want to deploy the honk verifier. Now deploy that. To say that the contract initialization data, whatever, again, it's with the optimizations, you could just make this go away. And I'm gonna as you could see in the function here, verify, it gets the proof and the public inputs. Usually you would have the public inputs in a contract. You would use another contract that will provide the public inputs. So you can, in this case, we are just calling the function directly. So just gonna pass the public inputs. So I want the proof. One way of getting the proof from that unreadable file, let me show that screen again. Where am I? Here. Can you see it? Can you see my terminal again?
No, still
to do.
Remix.
So
Yeah, no.
or still Remix.
Yeah.
Okay.
Yes.
Okay, now I see it. So the Remix will ask me for my proof, and I can't read this, right? So in the cheat sheet, I actually have a way of. I have written a way of making the proof look readable, because you could just go and cut, and it will look like this. So not really useful. So you could just go and you could also go with proof fields and remove all the 0x, concatenate all of this. It will work like do it like this and so on until you get the wall things. But you can see this will take a while. So I'm just gonna do it like this, copy and paste this thing. It will get me the proof in the readable format. So
Nice.
yeah.
Just a question, because I didn't see I was doing at the same time. Did you deploy the contract or not?
Yeah. Yeah.
Okay.
I'm gonna show you in a second. Just gonna
On
show
se-
you how I get the proof from this unreadable file. So I'm gonna copy this thing. I'm gonna put it in a file somewhere so I don't lose this. Just gonna put so I'm gonna put this in a note, like notes text. I have the proof here. It's not spell checked. Okay, it's fine. Okay, so I'm gonna go back to Remix now. Where am I? Remix. Yeah, here. Okay, I hope you can see it. So now I have my proof here. So I'm gonna copy this file this huge string here. Gonna place it here. I think it's not hexadecimal, so I actually have to add a 0x at the beginning. And then the public inputs will be just 30 zeros, and then 12, which would be the 18. I was gonna go and grab it from our target folder as well. Just gonna go, and these are like 30 zeros and the 12 that fits the space. And I'm gonna call it, like, and hopefully this will work. Let's see, pretty small, right? I'm gonna make it a little bigger. Okay, I don't want AI assistance. How do I remove this? Just go away. Go. You're fired. Okay, yeah. Just wanna clear some space here. Okay, so I have run this. Hopefully it went through. So you can see that's pretty expensive, right? 6 million gas, right? You can make this. We're actually improving this because we need this for. Oh, come on! It shows up on the other side. Just okay. Because we're using this for Elastic, so we are working on improving this to, I don't know, 10x or something to make it much cheaper. So I've called this, and it said pretty anticlimactic, but it will say verify true. Cool, that's it. Like, so my smart contract has verified that my age is indeed higher than 18 without I've never passed to the contract, but my age was right. All I did was pass the public inputs. And again, in a normal situation, this will be hardcoded in your contract. So even public inputs wouldn't be sent, it would just send the proof. So the flow would be me as Bob. I generate this proof, and then I send it to the smart contract. And the smart contract just verifies the proof and say, for sure, this person is older than 18. The problem, again, with age verification is that I can say whatever, like, it's just not enough. So people like ZK Passport, what they do is they verify that your passport is true, that it was signed by the correct entity using signature verification, and then using the payload in the passport that was verified to check your age and prove that it was higher than the whatever is the minimum age. So that's what they do. It's pretty interesting. If you want to look into their circuits, which is ZK Passport. Here they have a ton of stuff and a ton of tooling as well. Like, you can see the circuits. Pretty complex, but yeah. Cool. I don't know if you have any questions.
Yeah, the
So-
question I was when you deployed the contract, did you use
Yes.
an already deployed one, or you just deployed it with Remixed?
I just deploy with Remix, yeah.
And on which,
So I
because
pasted the contract that
yeah,
I pasted the contract, then I went here, Solidity compiler. I
yeah.
used an optimization, but you don't have to. I think it works without optimization. So I'll just complain more. So maybe even adding more rounds. I don't think this is how it works. But anyway, well, they went down. But anyway, I compiled it, and then when you go and deploy and run transactions, it is showing here already. So you can go with honk verifier, which is the only one which is not a. It's the only one that is not a library. All the others are libraries. So this is a library. So these is libraries that are used. So as you know, with Solidity, libraries are other contracts. So it just goes and deploys all the libraries, So if you deploy this one, it will deploy libraries and then the one that you want to verify, the one that you want
Okay,
to deploy. So
nice, I get
unverified.
it.
Yeah.
Cool.
Cool. More questions? Cool. So you will probably want to do this in JavaScript, right? So that would be the next step if you want to do a web app or something. So there's you go to noirlang, noirlang.org. Here's our nice website. You go into the documentation, and there's a tutorial on how to do that, building a web app with Noir and Bartenberg. So you could go through this. I think there was something that is not working because of Vite. I don't know if we have updated this yet. But yeah, we're gonna find out because this is hard coded to a version that works. But if you try with a later version, then you're gonna find out some problems. Because Vite, I think doesn't give you all the resources, something like that. But you would use a library called Noir.js, and Noir.js is and BPJS. So this would be like the libraries for compiling, executing, and then proving on the browser. And this will just make you. I think it's pretty stupid. It's also age verification, so it's not that stupid. But yeah, it's just an example. You could do anything with it. Yeah. Any more questions? Cool. Then let me just wrap up. So, yeah.
So sorry, I don't have a lot of information about Noirs, but I heard that they're using ZK snarks, right?
Yeah.
Isn't ZK snarks are, constant size, but what we have done, the proof size was changing. I believe I get that way. So I don't understand it.
Not anymore actually. With the latest honk, the proof size is static. Doesn't change.
Oh,
But there's that's not the biggest difference. I mean, the proof is much smaller than it is with Starks, and I think that's one of the biggest differences between them. The way that they work is also different. I really don't know. I can't explain much further
oh, I see. No, thank you very
than
much.
this. But I know that obviously Starknet uses Starks. I mean, it's in the name, Starknet. So I know that Starknet uses Starks, and Bartenberg uses Snarks. But they are, I mean, it's all ZK.
Yeah.
Right?
Okay. Sorry.
Yeah. Another question from Augusto? Yeah.
Yes. And my question is, what could I do if I need to generate a verifier for another network besides EVM?
Good question. So for Starknet, I already told you there was this Garaga Starknet. We're gonna find here, I have a blog post on doing that. So basically, you can write Noir and then verify that Noir proof in a Cairo program. So this is pretty cool. Really, really amazing stuff. So they'll have a documentation on how to do that. It's really cool. There is someone working on Solana as well, but I think they have successfully verified a Noir proof in Solana. I don't know if they are providing any kind of tooling or honestly, I don't know what's the status of that work. But I've seen on Twitter someone say, "Oh, I've successfully verified as an Noir proof in Solana," so that's good. And so far, I've not heard of any other smart contract blockchains that's verifying Noir proofs. Honestly, it's not that relevant. Maybe you could use it like to verify in a Cardano maybe, or Polkadot maybe. I don't know. There's other chains, but
Stellar, maybe?
honestly, Stellar, yeah, that's true. Someone was working on a verifier for Stellar. Yeah. But you can reach out to me in my somewhere in my link tree here, and I'll try to find what's the status of the Stellar integration.
And yeah, because now I am learning Stellar too, so I want to know how to integrate this Noir or
Yeah.
zero knowledge proofs with Stellar and make some applications there.
Yeah, there's a team working on that. So, but I mean, I don't know what's their status, and they're definitely maybe they will have to change something. I don't know. Maybe they have to change something in the Brandenburg or something. I don't know. I know that Garage had to make some their own flavor of Brandenburg to make it work with Cairo, but it's different, and it's actually pretty insane that you can verify a Noir proof in a Stark. But I mean, those guys, they're peak brain. I mean, the smartest people you can imagine. So yeah, Stellar maybe it's easier. I don't know.
Okay, thank you so much.
Cool. So let me just wrap up with the question that some people bring: what is the difference, or why is Noir used in Aztec? And you would be surprised if you go to docs.aztec.network and try to write a contract in Aztec and realize it doesn't look like Noir. So that's the thing. It's its own framework. It is definitely Noir, but it's not really a requirement. But the cool thing is that every program, every smart contract written for Aztec is a collection of circuits, collection of Noir programs. Each function is a Noir program. And so you can define them as being public or private, and that's exactly where they're going to be run. If they are run in public, then the node is going to be running that proof and passing it to be verified. And if it's a private function, then it runs on your phone, your mobile, or your device, and then you're sending the proof to the verifier. So the change that a Noir allows is from normal Web3 development that you say, oh, please do this for me. Here's the signature. And with Noir and Aztec, it's not quite the same thing. You're like, I did something. Here's the proof. So something has already been done. You just need to prove to the verifier that has. So when you send a transaction, you already sent it. You're just letting the node know that you have sent a transaction. Here's the proof that I've sent a transaction. So I usually joke and say that you could theoretically write a contract, deploy contract, mint tokens, send tokens in a plane without internet, because those are all private functions. So you could, in theory, you could do something like that. Because you're just telling what already happened. And this is the power that Noir allows that wouldn't be able to be done in any other language or framework. So that's why Noir is so important for us, and that's the relationship. But I would totally recommend you to go and try to write some Aztec contracts if you want to. Those are interesting. Cool. And that's it. I don't know if you have any final questions, then this is the time. Otherwise, I'm gonna leave my link tree here so you can ask me questions on Discord or Signal. Maybe Signal is easier because I don't usually answer messages in other places. But yeah, and I can help you with what you're trying to build.
Thank you very much. It was really, really good, workshop. I really
Cool.
enjoyed it.
Glad to hear. Yeah.
Do you have any other questions, people? If not, we can end. It was a long session. Thank you very much,
Yeah.
Pedro.
Thank you.
Yeah. And
Cool.
if you have any questions, as Pedro said, I think you can find him on Twitter or Signal. And thank you.
Thank you.
Bye.
Yeah.
Bye-bye. Take care, all of you.
Thank you.